Hey, welcome back to part two of the flower blooming series here. In the last part, I showed you guys how to make this little petal here that curls in on itself and animates. And in this part, we're going to be talking about how to create the phyllotaxis, which is essentially the mathematical arrangement of all these petals to make it sort of, arrange the way it would in nature so that they're not intersecting. And as I mentioned in the previous tutorial, I discovered this method through a dude named Constantine Magnus, which I think I showed you in the first tutorial. I want to make sure he gets credit for that. But I'm not just, we're going to be modifying, we're going to be taking his method a step further and using a bunch of mops to replace a lot of the stuff that he's done. Because even in his method, there's still like a pretty big chunk of code that they use to like rotate all the leaves and stuff. And we're basically going to be using a bunch of mops and fall offs and stuff to replace all that code and make it like way easier, way more beginner friendly. So yeah, let's get started. I'm going to show you kind of my method here of what he's done. So let's put down a line, and let me just template this here so we can see it. And you can just leave it at the default. That's fine. And then let's resample this. Resample. And I'm going to turn on the little dots thing so I can see what I'm doing. And let's put this to 0.05. And then we want to make sure that we give ourselves a curve U attribute. That is very important. Okay. Then we're going to use an attribute remap. And we're going to remap curve U to P, which is going to basically push it outwards to the side. So where the curve U is 0, the position is 0. Where the curve U is 1, the position is 1. Okay, and we can just leave that at default for now. All right, and then we'll do another resample. And we're going to name this point resolution. Point resolution. And I'll explain all this. We're going to build the setup first, and then I'm going to kind of go back and show you what each of these little things is going to do for us. So, okay, and what we're going to do, point resolution, change this to subdivision curves, and then 0.03 for now, but we can change this later. Okay, and then we're going to put down another attribute remap, and we're going to name this shape. And I'm going to make it green so I know that it's something that I want to, like a pretty important one. Okay. And again, curve U and P. Okay. Cool. So what we can do with this is we can alter the shape of it. Like this. And again, I'll come back to this in a sec, kind of showing you what we're doing here. Okay, the next thing we want to do is put down a wrangle, and this is pretty much the only code we're going to use. It's very simple though, and we're going to call this p-scale. So basically what we want to do is we want to make the p-scale, because right now we don't have p-scale, but if we visualize this, how to do that? Oh yeah, here, and then let's do lit spheres, right? Oh, yeah, lit spheres, but we don't have p-scale, so you can't see anything. What we're going to do is make the p-scale equal to x. So f at p-scale equals v at p dot x. So basically, what that's going to do, let's see if I copy 2 points, maybe I wonder why it's not displaying here. Maybe I need to reset my viewport. It should be displaying. Always need to reset my viewport. So dumb. Well, that's not working either. Okay, so let me just copy a sphere to these. That'll give us a better idea. So you can see the p-scale is equal to the x value. So where the x is 0, there's no p-scale, and where the x is 1, it's gigantic. It's 1. Does that make sense? Okay, so what we can do then is we can then reset this line, so we can say v at p dot x equals 0. So that will reset the whole thing back to being a linear line, but the p-scale stays the same. Get it? Okay. So, cool. Again, we'll come back to this in a minute. Okay, the next thing we want to do is we want to put down a sweep. and put this in here. And we want this to be a round tube like this. And the sweep, what it does is it actually adheres to the p-scale that you define. So you can see that, you know, we have 0 thickness here and then a 1 thickness here. And what I want is, instead of quadrilaterals, I want points. And then for the columns, I only want 1. And the radius, I want it to be 1. So now we're kind of back to what we had before a little bit. And then what I can do down here, where it says partial twist, we can use this sort of like magic number, 137.508, and that twists it. And so this number, if you've ever worked on flowers or anything before, this is just sort of this like weird magic number that's found in nature. That's like, that's how much everything is rotated by. It applies to like every plant in existence. So if you can just remember like 137.5 or 137.508 more specifically, it like rotates it perfectly. And then we want per edge here. And so what you can see is, you know, it's kind of difficult to see right here, but if you look at it from the top, we now have a phyllotaxis. And what you can do, let me get rid of this thing and just go back to points. What you can do with that is, it's a little easier to see if we come back to this shape and we make this, you know, you have control over like where the points are. Kind of cool, right? Maybe we set this to, or maybe we set this one. You have a little bit of control over that. Okay. So, but yeah, again, if you look at it from the top view, where are we at? 2? Yeah. Now you have a phyllotaxis. And with this resample here, with the one that says point resolution, we can control how many points we have. So there you go. See, now you have a phyllotaxis. Super simple, right? Like the coolest method ever. It's like so many tutorials I saw use like so much code to make this. And this is just like a great method. I really like it. Okay. So there's more though. We're gonna add some rotations. I'll show you guys how to adjust the shape, because right now we have this like cone, but you know, of course we can adjust the shape of it. So, you know, if we wanted it to be like this, we could, or let's do a hill. Where's it at? Why am I not seeing hill? Yeah. So like this, so you could make, you know, from the top, it's still a phyllotaxis, but you could make plants that are like, you know, growing vertically with things arranged on it. For now, I'm just going to use linear. That's fine. And we'll come back and we'll modify this in a minute. Okay. The next thing we want to do is put down another attrib remap. And we would like to make this green again, because it's going to be an important one. And we're going to call this one scale. And what we want to do to visualize this, let's change this back to lit spheres again, is we're going to go p-scale and interesting. What am I missing here? Yes. Okay. I remember. So the reason everything disappeared when we put this down is because when we put this sweep node down, there's something we have to do in the UVs and attributes area where it says attributes from backbone curves. You basically just want to remove this little caret from the p-scale so that it passes through. Okay. Or so that it doesn't pass through. It doesn't pass through the p-scale. So now, or actually, let's see if we like this and hover over it, we don't have p-scale. But see, it's blocking the p-scale basically when we put the sweep node down. But if we remove this little caret, suddenly we have p-scale again, and we're able to manipulate it here. Okay, so now we have control over the p-scale directly with this thing. So we can make, you know, if we look at it from the top view, spacebar 2, with this side, we can manipulate how big they are in the center. And with this side, we can manipulate how big they are on the outside. So you have some control over that, which is pretty cool. And of course, you can adjust like the output minimum and maximum to make this a little easier to use for yourself. Okay, so we're getting there. We're giving ourselves little controls here. Okay. And the next thing I want to do is I don't, for now, we could build a plant like this. Like if you look at sunflowers or if you look at some types of plants, they have this sort of vertical arrangement. I don't want it to be like this. I want this to be flat. So what I'm going to put down is a transform node. I'm just going to call it flatten. And I'm just going to scale the Y height down to 0. Why did that do nothing? Strange. 1, 0. God. Is this my scene view again? I swear to God, if this is a thing of the scene view. It is. God damn it. I always have to reset my viewboard. Maybe I need to upgrade my Houdini to a different, because I have Houdini 20.5.332. There's probably a newer version where they solved this issue or something. I have so many issues with my viewport all the time. So, okay, so basically I'm just taking the original and just flattening the Y height to 0. So now we have this phyllotaxis here. And then I don't want it to be that big. I want it to be kind of shrunken in. So I can just scale it down to like 0.37 or something like that. So now I have my little phyllotaxis. That's great. Okay. And then what else do I need? So if we click this little button, it's going to show you sort of how things are going to arrange themselves. So if we copy this leaf, or let's put down a copy to points and take our out petal and copy it. Okay, so to better illustrate this, you can see they're all arranged like in the same direction. And, if we get rid of that by clicking this little button, you can kind of get a visualization. So that's not what we want. We want these to be arranged sort of like outwards, each one. So the way we're going to do that is we're going to use, I think, our last little piece of code here, but don't worry, it's very simple. It's not like a block of code. And we're going to call this set n and up. Okay, so let's hover on this here. And basically what we need is v at n equals v at p. Okay, and what we can do to visualize that, so we've now given ourselves a normal. You can see, if we click this is our normal attribute, pointing outwards. But they're short on the inside and long on the outside, so we need to normalize that. So we'll go normalize, basically, and then just put this in parentheses. What that does is it just makes them all the same length, 0 to 1. Okay, so now we have the outward part, but we need the upward part too. And I want them to be pointing up in Y. So we're going to set a value, attribute called up, v at up, and equals. And then we can just do these little curly guys here, curly parentheses, and we'll go 0 in X, 1 in Y, 0 in Z. So that basically means point up. Okay, and then if I visualize this up, you can see we have up and we have our out. Okay, cool. So then what I can do is, let's unvisualize this. Get rid of that. If I hover over this now, it does nothing. Cool. Why does it not show me anything? But I wonder, let's see if no? Oh, because I need to plug this in here. There. Now they're all arranged correctly, except my leaves are kind of twirled the wrong way, but that's an easy fix. I can either come over here, put down a transform, and just rotate it 180 degrees like that. And now it's fixed. And I can, scale these up so I can see them better. Or I can, rotate them over here if I wanted to. But we have them arranged correctly. So look at that. It's an easy way to make a phyllotaxis. And we have control here. We can change the scale of things. So we can make the outside larger. We can make the inside. Actually, let me just put that transform back down here so it'll be easier to visualize what I'm actually doing. 180 like that. And so we can rotate them like that. We can have, our scale. Great. If we want the inside to be bigger, maybe have the outside be smaller. Cool. Okay, so we've got our scale stuff, and we can have control over the shape of everything. We can make this, come on, more. You can unflatten it if you want, and have it be arranged like this if you're making like a taller plant or something. But we're not able to rotate them yet. So how the hell do we rotate them? Well, I think we can just put down a MOPS transform. Nope, not that. So I want to do right after the set N and up. Let's do mops transform. Where is it at? And this is part of the free mops, by the way. So if you don't have mops plus, which is the paid version, this is the free version. Is transform. The mops transform is like super useful, and that's great because I can just rotate stuff. I don't like you can avoid to do this. You would with code, you have to use this like giant block of code with all these like quaternions and radians and all this bullshit that I don't really want to do. I just want a node that fucking does it, and mops does it. So use it. So cool. Now we can rotate this, but they're all rotating at the same level. What if I want the outside ones to rotate further than the inside ones? Well, the great thing about using the mops transform modifier is that it allows you to use a mops fall off as well. So what we can do, let's put down a mops shape fall off, mops shape fall off. And let's visualize this here. I'm going to turn off this thing, preview fall off, and maybe I'll make the background dark so you can actually see it. Get rid of this grid. Okay, and what I want instead of linear is I want spherical. And you can see on the inside, well, the white part is a value of 1, the blue part is a value of 0. So let's get this just so the outside is like just at 0. And then we can adjust the inner and outer radius to kind of make this like that. Okay, let's leave it there for now. So now we have our mops shape fall off. And then if we come back down here, by default, the mops transform modifier has do fall off enabled. So this is what we originally had, but with fall off enabled, now when we rotate stuff, looks like the inside rotates more than the outside. So I think I actually want this to be the other direction. I want the outside to rotate more than the inside. So we go back to our mops shape fall off, come to remap, just hit fit, and then just hit this button and it'll reverse it. There. So now that looks better. The outside should be rotating more than the inside. And so let's arrange this like, I don't know, something like this. And then of course we can come back to our mops shape fall off and we can, you know, animate this. Do you guys kind of see where we're going with this? So it's becoming more controllable. So you have a lot more control with this mops stuff. Cool. Okay. So great. And I can disable mops, this preview thing here. And I can, you know, of course, change the fall off to be like this, like really small. Maybe I don't want to go negative, but it's maybe 0. Let's try that. I don't know. Maybe 0.001. I don't know. Okay, we'll come back to it though. But you can see where we're going. Now we're starting to get somewhere. We have this, you know, we have this control here. Okay, cool. Great. So how do we, I think that's mostly it. We're going to add a few more things, to this as we need it. But for now, let's try to get this to animate the way we would want it to animate. So the way that you need to do this in Vellum is you can't have things starting intersecting. They need to start apart. And because if you have things starting, like right now, you know, the outer ones aren't really intersecting, but these inner ones, they're intersecting. And if it on the first frame you have intersections, it's going to mess up the simulation. It's going to get all jittery and stuff. So we need to find a way to first de-intersect everything and have them sort of like move from apart to together. And then from there, it needs to animate closed. And then we will play it in reverse. And this will be more apparent as we do this. So right now, if I hit play, we still have our animation that we've created here, right? Of our single petal closing. Okay, that's cool. But I want them to close one at a time. How do I do that? Well, first, actually, let me just bend this a little more. Something like that, I think, would be good. So basically, what we want to do is on this first frame, we want this to look as close to the final bloom state as possible. So we have to kind of do some work here to kind of get it to do what we want. So right now, this doesn't look like a great bloomed flower. So first of all, I have all this space down here. I want all these points to be like from the center. So what I can do is I can come back up to my flatten node, I believe, and I can shrink this down even more so that it's like this. And, you know, maybe I need to put my MOPS shape fall off before the flatten node. Or, you know what? Because as I flatten this, if you look, and let's preview the fall off. As I flatten this, it moves through the fall off and it's changing things in a way that I don't want them to. So maybe what I'll do is I will bring this back up to 1 here for the flatten, and then I'm going to put down another transform. I'm going to call this shrink. And actually I want this to be after the MOPS shape fall off. So that way, when I come here, if I shrink this down towards the center, the MOPS fall off stays the same because we've done it before. So when I come back here, I can go shrink. There we go. That's way better. Okay, so I can have these kind of be, I'll bring this down like almost to 0 so that there really isn't like a gap there. Okay, cool. So that's helpful. And then let's try to arrange this with the MOPS transform. Something like this. Maybe let's bring the shape fall off. Let's bring it back up to like 1. Transform modifier. Something like this. And I think I want the scale of things to be more small in the middle. So if I come back up to scale, there we go. That's looking better. Do the outer ones could be 1. It's looking a lot better. Okay. Now you don't want the middle to be 0, by the way, because you can't also, Vellum doesn't like things that just aren't there. Like it's still counting that there are points and geo there. So you want it to be like just above 0. Something like that. Okay, cool. So we have this. That's great. And so probably like something like this is going to be my end state. And if I want more leaves or more petal, I keep calling them leaves. I don't know why. But if I want more petals, I can come back up to this point resolution, and let's make this green as well because that's a important node. And I can, you know, make less of them or make a lot more of them. And then I can, with the shape here, kind of adjust how things, you know, I can make the center more open or kind of make it, I don't know, like this. That's kind of nice. And maybe the point resolution, I'm going to bring it back up so that we don't have so many to simulate. Do something like that. Okay, that's looking cool. Okay, that's looking more like a good bloomed flower. Maybe a few more would be nice. Okay, cool. What else can I do? The scale. Yeah, we've already kind of done that. Maybe I can make like this, or I don't know. I think that's probably pretty good. Okay, so we're getting there. So cool. It's looking nice. So I can have these all close at the same time or open like that. But basically, I think probably something like this is going to be my end state. Okay, that's looking pretty good. But still, everything's happening at the same time. How do I offset the time of everything? Okay, so I'm going to show you a way to do that. So, and maybe for this transform here, let's put this up here. I'm just going to call it rotate 180 so we know what it's doing. Okay, so to do that, how do we affect each one of these things individually? Well, you can't do that just with a normal copy to points. You have to put it into a for each loop. Okay, so what we want to do is do a for each point, and we can then disconnect this, and I want to put this in here and this here, right? Yep. And then come back here and plug that back in. So basically all we've done, oh, and then plug this here. All we've done now, it looks exactly the same as before, but now we've just we're having this for each sort of like intercept the points. So now whatever we do in here can affect things individually. So what I want to do is I want to put down a time shift up here. And basically I want to time offset each one of these things. And the way to do that, well, let's first create our, where is it at? Up here, create meta import node. And I like to rename this to info so that it makes it a little easier when we type our little code thing here in a second. And then the last thing we need to do over here is we need to create an attribute for a time offset. So let's put down another wrangle. I guess I lied. Maybe there is one more little piece of code, but it's simple. Okay. And then I want to put down a null just here. I'm just going to call this out philotaxis. Damn it. Out philotaxis. Okay. And then we're going to call this time offset. And what I want to type here is I want to create an attribute, and you can call it whatever you want. So I'm going to call it f at time offset. Time offset. Okay. And what I want to do is make that be equal to mops fall off 2. Mops fall off 2. And then we will put a, well, for now, let's just leave it like that. And we need to set up more. So right now we don't have a mops fall off 2. We only have mops fall off here that we created. So we need to create a second mops fall off. And the way I want to do that, they have this great, mops fall off. Instead of using mops shape fall off, we can use mops fall off from attribute. So I will show you what that does. If I put this here and hit preview fall off, it does nothing. So I put down this mops fall off from attribute, and the attribute it's trying to create a fall off from is ID, which we don't have yet. So what we do have is ptnum. So if we hover over this little number thing, we have numbers for each one, but that's ptnum. So we could just change this to ptnum. So let's do that. And that should work. And it is not doing shit. What is ptnum? We do have a ptnum though. That's interesting. Okay, well, let's change this back to ID, and then let's just come back up to this set n and up wrangle, and let's put a new little line of code, and let's just say at ID equals at ptnum. That should take care. Okay, cool. So I guess it needs an ID. Even if we have ptnum, it needs to be, the attribute needs to be ID. Okay, so let me just undo all this. So now what we're doing is basically, so we've had this mops fall off here. Let's turn off the preview. And then we put down the second one here that's creating a fall off based on our ID. So if we go like this and make the ID apparent, so you can see where the ID is 0, the number is 0, we have a fall off of 0. And where the ID is highest, like 47 or 48, the little dot is white. So basically it's creating a fall off based on each of these numbers. So what we can do with that is then create a time offset. So, let's rename this. This mops fall off from attribute, let's make it mops fall off 2. So now we should, because I need to put an at symbol here. That's why it's giving me this little error. There we go. Now we have a time offset based on this mops fall off. So basically where the mops fall off is 1, it's going to trigger that animation first. And where the mops fall off is 0, it's going to trigger that mops fall off last. Does that make sense? Cool. So, and then what I want to do is I want to add a little bit of a multiplier here, so that I can offset it even further. So in between this, I want to put a little multiply, and we're going to create a channel float for ourselves, and we're going to call it offset. And then I hit this little button here, and that gives me this little thingy here. So basically I can offset this even more. So right now we only have a value from 0 to 1. So it's only going to offset it by like 1 frame. So the difference between the offset of here and here is almost nothing. It's almost going to be imperceptible. So we want to multiply this by like 50 or something, so that the outer ones now like are going to start 50 frames before the inner ones. And that'll be a little bit more apparent when we actually do this here. Okay, so for right now, if I come back over here and I hit play, there's no difference. Everything closes at the same time. So there's still one more step I need to do. So I have this time offset thing here, and I have this time shift over here, but how do I get the offset information from here to here? Well, the way you would do that is with a very simple little expression in the time shift. So we come over here and we're going to say $FF plus, and then we're going to use a point function. So if you're familiar with the point function, we use this it's like the most basic vex that there is. Basically, it allows you to retrieve an attribute from a different piece of geometry and pull it into the current piece of geometry that you're using. So we're going to use that to retrieve this attribute and pull it over here. So we're going to go point, and then, but we don't want it from here. We want to get it from here. And so we want to go, where's it at? I guess we didn't need this info thing, but what is this called? For each begin 1. Okay. Let me just pull this down here so I can actually kind of see what I'm doing. So point, and then what we want to do is type quotation mark, // and that kind of goes up a level to look for something. And then for each begin 1. Yeah, this one here. So we want for each begin 1. And then we want to close the quotation mark. So that's saying search for the attribute in this node. Then we have to define, we'll just put 0 here. And then the attribute we want to look for is T underscore, or not T underscore, it's a time offset. I think that's what I named it, right? Let's go here and let's verify. Yeah, I just named it time offset. Okay, so come back here. Time offset is the attribute. And then again, comma 0, and then close the parentheses, and that should do it. Okay, cool. So now you can see everything sort of jumped. So let me sit. So what's happening is that the ones in the center aren't getting any offset, but the ones on the outside are getting an offset. They're now 50 frames ahead of where they were before. So if I come back up here and I move this back, you can see that the ones on the outside are moving faster than the ones on the inside. But I don't want it to start here. I need to kind of back this up a bit. So what I can do is I can go minus, and then I will put a offset here. Let's say 30. Okay. So have it. Oh, that's all messed up. Why is that? Maybe you just scrub. Interesting. It's doing something, but what am I missing here that is making it not do what I want? Okay, so my bad, guys. I was looking at one of my older setups, kind of referring to this. We don't actually need that MOPS. We don't need an ID. We don't need a MOPS fall off from attribute. Just this one MOPS shape fall off, the original one we built, is sufficient. Okay, so what we can do is we can remap this to, so we still want this to be MOPS fall off 2. Everything else is the same, but you can delete that MOPS fall off from attribute, and you can come up to your attribute wrangle and you can delete the ID. We don't need that. I'm really sorry. So I kind of fucked that up. It's even more simple than I thought. Okay. So what we're going to do is we're going to put down a MOPS remap fall off. So after our MOPS shape fall off, we're going to say take mops fall off and rename it to mops fall off 2. And then what we want to do is I don't want the outsides to move faster. I want, here, let's visualize this. I want it to be the opposite direction. So now we have 2 attributes. We have left our original mops fall off unmessed up. It's the exact same as before. And then we now have a new mops fall off based on our old one that we can then adjust here with this. So when I hit play, on here, it should do what I want. So the inside is moving first. There we go. It's working. Look at that. Okay, and then again, we have control over how much time offset we have. You know, we can set this down to like 20 if we want and have the offset be, so now they all happen closer together. So if I set this to, you know, back to 1, it's basically, they're almost happening at the same time. So if that's what you want, great. But then you can, of course, you know, come back up and make it more apparent. Make these like, you know, if we set it to like 294, now there's like, they happen like really one at a time. So I found for me a value of 50 seems to work pretty well. So it seems like, you know, they all close individually, but they're not happening too far apart or too close together. Okay, cool. And then again, over here in this time shift node, you know, you may need to adjust this number. So this minus 35, you're kind of offsetting it even more. So just so you know, you can middle mouse click over this number and just kind of scrub and have it be, so like, let's say I think I want the end state to be like this. That's kind of good. Cool. Minus 30 seems to work. Okay, cool. So now I hit play and we have it. Okay, great. So what we're going to do is we're going to put this into a Vellum simulation. We're going to simulate it closing like this. And then once we save that out, we'll just reverse it so that it opens. But right now it's still not doing what I want. They're all sort of like rolling in on themselves, but I want them to sort of also tilt inwards, because like this doesn't look like a flower bloom to me. This is sort of this weird little, it's not doing what I want. So I think I need to add some more animation up here. So let's come to our petal. And right now it's doing this, but I think I need to also, let's come back to this. I also need to have it bend forward or sort of transform, rotate forward. So let's see, let's have it, so it's rolling. Maybe I'll put a marker there, and then I come to where it's like this, maybe 72 frames, and I'll have it rotate forward like that. So let's see what that looks like. That's a little better. And then come back down here and let me put a little, make this green so that I know that I've done something there. So if I come back to this and see what that does, let's look. That looks better. So now that they're actually colliding with one another. So maybe if I come here back to frame 72 and I can adjust this maybe even a little more like that. That seems pretty good. Okay, cool. So it kind of takes some like back and forth fiddling with little things to kind of make it look the way you want it. So cool. All right, so that's looking pretty good. So, but now you can see these are still intersecting, right? Like there's still some intersections here, and we can't have things start intersected. So what I want to do is a great little trick you can use to animate these closing. So for right now, if I put this right into Vellum, it's just going to immediately start closing and it's going to get all fucked up. So what I want to do is I want to give myself a little bit of space to have a de-intersection animation first. So let's put down a time shift after this. And let's say, let's go $F minus 120. So what that's going to do is it's going to give me 120 frames where nothing happens, and then it's going to start closing. Okay? So that's sort of, so I have 120 frames to make this de-intersect first, and then it's going to start closing. So the way I'm going to intersect it is I'm going to use a exploded view. And what this does, it's great for stuff like this. It basically just kind of pushes everything outwards. So now, well, we still have some intersections there, but I can scale this like this, kind of scale it outwards. It's working mostly, but these middle ones are kind of they're still kind of messed up. So I'll probably need to come back and adjust some scaling. So maybe so let's come back up. Let's go to like 1. So this should work pretty well. So basically what I'm going to do is I'll show you is basically animate it in. So we're going to have it sort of start exploded, and then we're going to just kind of keyframe it into this. So we'll run a vellum simulation from, I don't know, let's have it go from 2.5, and then we'll come down to 96 frames, have it kind of go slow, and have it go to 0. So it's going to look like this. It's going to animate in. Everything is going to de-intersect in vellum. The collisions will all work really nicely. Give it a few seconds to settle, and then it's going to close. But we still have a little bit of work to do with, why did it do that? What just happened? Why is everything closed? Oh, is it my viewport again? It's probably my stupid viewport. No? The fuck? I don't know what that was. I just kind of clicked around and it went away. So it's just some sort of bug. But you can see we still have these intersections on the middle ones. We can't have that. So what we're going to need to do is probably come up here to the scale or something. And maybe I want these middle ones to be like really small. Let's see. Let's get in there so we can see. Yeah, something like that. Just kind of adjust it until these aren't intersecting. I think that's a decent way to do it. Oh, these still need to be not 0. Right? Cool. I don't think anything's intersecting now. Okay, cool. And then what's that going to look like? Let's make sure the flower still looks good before we've time shifted it. Yeah, cool. So basically just kind of tweak it a little bit. So some flowers are they're a little complicated by nature, but just you kind of have to fiddle with it a little bit till you get a result that works. So basically now nothing is intersected. We have them animating inwards. And then we have it settle for a minute, and then everything closes. Great. Okay. So I think we're going to stop it there. That's enough for this one. In the next one, I'm going to show you guys how to actually put this into the vellum simulation, some settings. We'll kind of go back in and we're going to maybe add some more detail and some noise to the flower petals so they don't just look, very flat. We want to give it a little bit more character. And then we'll move on to like lighting and texturing and stuff. But this is sort of the basic setup for the Phyllotaxis. And, again, you have, let me just get out of this. You have a lot of control over the scale of things. You can, of course, make this larger. You can give it, less petals, more petals, like a shitload of petals. You have control over the shape of everything. So with these little sliders here, so you basically have, full control over, how much things open. It's great. So it's all just like mops, fall offs, transforms. It's great. I like this method a lot. So I hope that I didn't confuse you. I'm sorry I made a mistake with that mops remap attribute thing. It's much simpler than that. You really just need this one MOPS fall off, and then you just remap it into MOPS fall off 2. And then this time offset thing, it's, it sounds a little complicated, but basically we're setting an attribute called time offset. We just made it up, and the time offset is equal to the MOPS fall off. And then we just offset it, multiply it by 50 to make it even more apparent. And then from there, we've basically used we don't even need this info. I don't know why I put that in there. I'm sorry. Just get rid of that. It's just confusing. We can just put it into a for each loop, and then use a point function from our time shift here to reach into this node and pull out the data of the time offset, and basically use that to offset every frame, basically, or for each one of these points, we're going to offset by 50 or whatever. And that's it. And then we've done our little exploded view thing here. So I'm sorry if this was a little confusing. This is probably the most confusing part of building flowers, is the phyllotaxis and the time offset. But the vellum part is really easy. The rest is really easy. Lighting and shading, it's really easy. And building our little petal is really easy. So if you can wrap your mind around this part here, this is the most complicated part of building flowers. And so if you've done it, great. All right, that's it for this lesson. I will see you guys in the next one, where we'll have some fun and really simulate this thing and make it look awesome. All right, bye.